To load the Campus Modeler tool, go to the Plugins menu and navigate to Salvage Prototype, Campus Renovate Modeler, and load Campus Model. Once we select the appropriate file, a 3D model of the East Bank campus opens up. We can see that all buildings are modeled in 3D. You'll notice below that several windows opened up with our campus model. To demonstrate what these do, let's select a building to study. First, let's select the building icon in the tool ribbon, and then select Tate Lab. After a resimulation, we have some baseline site and building performance data for our selection. We can see that everything is grayed out except Tate and its immediate site. To expand our analysis area, let's slide the scale bar to the right. When we do, we can see that the performance box numbers and the selections box have updated. Let's see what happens when we slide the bar all the way to the right. Now, the entire campus has been analyzed. The performance box and selections box have been updated to include all buildings and sites on campus. Let's go back down a scale. The site and building icons allow us to select and deselect. Let's deselect some of our surrounding buildings. This is useful because we may want to analyze Tate and its surrounding sites without any other buildings, or we may just want to analyze a site. Once we are finished deselecting, a simulation is run and our boxes are updated once again. Notice how Tate is the only building listed in the selections box. Let's go back to the building scale to demonstrate the optimizer, which is also found in the Plugins menu. The optimizer is a multivariate approach that uses fuzzy logic to narrow the number of simulations. Selecting this tool opens up a wizard. Because Tate is an existing building, I won't optimize the form, but I will optimize the building envelope. Let's optimize all the strategies except for glazing properties. Let's skip passive and optimize daylighting. Here, let's only optimize the first two. Next, we have renewable energy, and we'll optimize everything except wind. And finally, for rainwater, we'll only optimize captured devices. The optimizer would normally take longer, but is sped up for this demonstration. When the optimizer is finished, two windows appear. The smaller window is for choosing the optimization criteria, and the larger window displays the optimized values. We can change the criteria to a number of options, such as water savings, carbon reduction, and net present value. Lastly, we can apply these optimized values to our model. Once updated, we can see that these optimized strategies have improved our building performance.